This is the second video of this problem. So if you haven't watched the first one, go back and do that before you watch this one, or you'll be kind of lost as to what's going on. So again, this was the titration of a weak base. I know that because the pH is high to begin with a strong acid, and you can see the pH decreases as you go through the process of adding the acid. So we are to point D, which is the equivalence point of this this titration. So the way that I know where the equivalence point is, there are a couple of ways you can calculate it. And with this problem in particular, we had question C, which asked about the midpoint. We figured out that that was the midpoint. And so in this case, I knew that I was at the midpoint when I had 20 milliliters added. And so if that's halfway, then 20 times 2, or 40 milliliters, is going to get me to the equivalence point of this titration. It didn't tell me that in this case. Sometimes it'll just say, you know, what is the pH at such and such milliliters, and that is the equivalence point. But that's not what they did here. You had to kind of figure it out for yourself. But that was a pretty easy one to do. So the other thing I need to know at the equivalence point is the total volume. The buffers, I don't need to know volume because it cancels out if you were to calculate molarity, so you can just look at the moles there as we've been doing. But I started this problem with 20 milliliters of the codeine solution. At the end point, or equivalence point, I've added 40 milliliters of the acid, so that is 60 milliliters total. And so this is the reaction that's happened. The codeine plus the hydrogen from the hydrochloric acid gives me the conjugate acid of the codeine. And at the equivalence point, of course, these two amounts for the acid and the base are equal to each other. That is what's equivalent at the equivalence point. So I've used up completely the amounts of both of those. I have no reactants left over, and then I've added that much of this conjugate acid. So what I've got at this point, again, is just the weak conjugate acid of that base. And so I have to have a molarity for these weak acid or base problems. Sorry about that, my camera slipped a little bit. So here is the molarity. I've got that 0.040 moles, which I have from my BCA chart here. The 60 milliliters, this is where I use that. It's going to become 0.0600 liters to give me 0.0667 molarity. 0.040 divided by 0.060, and that's my molarity. And so this is the reaction that's happening with this 0.667 molar solution of the weak conjugate acid. That acid is going to dissociate into the codeine and some H+. And so it's not going to be a huge dissociation, because remember the Ka that we calculated back in step B, it's 6.25 times 10 to the negative 9. Very, very small. But there is some hydrogen ion that's produced, and so I am going to get an effect on the pH from that. So I'm going to plug in my Ka in my equilibrium expression. Products, x times x gives me x squared over the reactants. Again, I'm going to ignore that x. It's going to be so small, it's not going to make a bit of difference when you subtract it from 0.667. And when I solve for x, it's 6.46 times 10 to the negative 5th. So again, if I look at what x is, it is a hydrogen ion concentration. So I can use that value to find a pH. Negative log of this number gives me a pH of 4.19. So that's the pH at your equivalence point. And it should be acidic since you're now working with a weak acid. Now the final region, or the final step in this kind of calculation, is something that happens after you get to that equivalence point. So point E. So what is the pH? Calculate the pH after the addition of 50 milliliters of 1 molar HCl. So in the last step there, we figured out at 40 milliliters, we are at our equivalence point. And so this is 10 milliliters beyond that. So I'm going to look at how much of each substance I have. The codeine, again, didn't change all the way through. I have 0.0400 moles of that. For the acid, it's 1 molar, so 1 mole per liter, times 0.05000 liters. That's 50 milliliters. Of course, liters cancels out, and you get 0.0500 moles. So here's the reaction that's happening. And again, whether or not you write this out, it's really going to be helpful if you understand what's going on in each of these steps in terms of the reaction. So there's my amount of the codeine. Here's my amount of the acid before the reaction. None of this conjugate acid here. And now the codeine is the limiting reactant. So I'm going to subtract all of that from both the codeine base and the strong acid, and I'm going to add the 0.0400 for my conjugate acid over here. And so this is what I have left after the reaction's over. In this case, I have just some straight out strong acid left. And so that's going to be what determines the pH at this point. So again, with this, you have to think about the total volume. So I have 20 milliliters of codeine, 50 milliliters of the acid solution. So the total volume now is 70 milliliters. From my BCA chart, I've got 0.0100 moles of the acid in 0.07000 liters. So just converting milliliters to liters, moving my decimal 3 places to the left. And that gives me a molarity of 0.143. So again, this is a molarity of hydrogen ions. So I'm going to take my pH directly from this. So pH is negative log of 0.143. You can see it's very, very low at this point. It's 0.845. And so that's all there is to it. Now, obviously, you know, amounts can change, but the process there is going to be exactly the same, going from no acid added all the way up to excess acid. So I hope that was helpful. I hope you're ready to start the practice problems. There's just one problem with several parts. And so try that, check your answer, and we will talk about any problems or questions you have next time we see each other in person. So I will be talking to you soon.